The rational zero theorem gives you a way to target values that you can use to find zeros. So this is a way to make a list of zeros based on the constant and the leading coefficient. So here's how it works. You take your polynomial, like in number 3 on page 206, which is 6x cubed minus 5x minus 1, and you make a list of all the factors of the constant. So in this equation, p is equal to -1. So all the possible factors for p are going to be plus or minus 1. You have to include the negative as well as the positive factors. Now Q is based on the factors of the leading coefficient, which is 6. So Q's factors are a list of plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now what we do is to make our potential zeros, we make a list of the ratio of P over Q and all the possibilities of that. So our P's over Q are going to be taking, now this list is going to be short because we only have one for P. So it's just going to be 1 over each of the Q's. So we're going to have plus or minus 1, then plus or minus 1/2, plus or minus 1/3, and plus or minus 1/6. So those are all our possible zeros. Now what we're going to do is we're going to use the factor theorem and substitute each of those, and we have 8, 1, 2, 3, 4, 5, 6, 7, 8, 2 for each number you see there, into the function to see when the remainder would be 0, which is the same as substituting and finding the value. That's the factor theorem. And when I did this, what I found was the only one that works was f of 1, which came out to be 6 times 1 cubed minus 5 times 1 minus 1, and that gave me 0. So x equals 1 is the only rational zero.